Welcome everyone to the Tulsa.net user group. Tonight, Kevin Griffin, a fellow MVP, is here to talk to us about tactics for building background services in .NET. Kevin, this is a new talk, and I'm really thankful that you're going to do the talk here for the first time. So go ahead and tell us about yourself and take it from here.
Sure, absolutely. So definitely a new talk. I've been playing around with this particular idea in my head for the past couple months because I did a workshop earlier this year, and it was all about building production applications in .NET. And one of the things that we kept coming back to was background services and doing stuff in the background. So I'm going to touch on that in a story here in a moment. But that's kind of where this idea came from. I'm trying to elaborate on it. I might slip up a couple times because it's a new talk. I've only walked through it in my head and here in my desk all by myself. So if you have any feedback, I would greatly appreciate it. And I'll do intros and all that stuff here in a moment. So first I want to start with the story. I asked the Midjourney to draw a picture of email causing a fire. And this is what it produced. And I thought it was hilarious, so I put it in the deck. But I want to tell a story about an app I worked on a long time ago. Not going to give away any trade secrets, not like you would want them anyway. But we have this app that had this fun little purchase button on it. And you probably have seen buttons like this in the past. When you click on them, you expect a certain number of things to happen. So if you click purchase, we go to the back end, the browser starts spinning, and we create an order. So there's a shopping cart, we go create the order. There's a whole bunch of stuff that needs to happen. And this is all happening after you press the purchase button. So we create the order, we go to the database, we do that stuff. Leaving out some of the details, we basically have to go make sure we have the appropriate inventory that the shopping cart said that we were going to sell. We go and then we charge the credit card for the amount that we said we were going to charge it for. And then we turn around and we send an email. And when all this is said and done, remember the browser is still spinning, it's doing its work. We send back the response and the user moves on. They do the stuff that they're going to do. And 97.2% of the time, this works fine. Like you press the button, spins for 5, 10, 15 seconds, and then it completes and it goes off to another screen. But there was this pesky little problem when I was coming onto the project where sometimes something as easy as the email would just explode. And what would happen is we would create the order, we would check the inventory, we would charge the credit card, and then we were trying to send the email, and that would crash the entire process. And the user would get an error screen. It would say, hey, there was an error with your order. I don't remember what it did. I don't think it was like a try again. It was probably like contact support or something. But it charged the credit card. And it took a significant amount of time, even when it was working, to get from the point where you press the button to when something eventually happened. And I remember going in and helping refactor that entire process. So that's kind of leading me into what we're talking about today. So those of you who don't know me, my name's Kevin. As Sean said earlier, I've been a Microsoft MVP for over 13 years now. Been focusing primarily in ASP.NET, ASP.NET Core now, Microsoft Azure, and everything web development. I love building web applications and platforms for businesses. If you ever like to talk to me afterwards, consultwithgrip.com is my website, where I've actually been putting up some material related to this talk. And I'm still on Twitter as long as Twitter's still around. And I'm also on Mastodon now, because that's where all the cool kids are going off to, bbiz.io @1kevgriff. I have a course that I've been hawking for about 2 years now on Signal R. So if you're interested in building real-time applications in .NET, go check out Signal R Mastery. I have a special coupon code for Tulsa.net. Sean will make sure everyone gets this, but for the next 5 days, you all get it for free, who've attended this talk live. So go get it, no cost to you. My only request is if you take the course, you give me a 5-star rating, because those stars help so much to the people that are paying. So give me 5 stars and we'll be good. So let's jump into kind of the meat of the talk. I have a lot of demos I want to go through. I have a couple, at least 4 or 5 different topics that I want to touch on. My goal here is to talk to you about why it's important to do stuff in the background. Because I think a lot of developers, especially those coming fresh into the industry, they don't think about work that should be happening somewhere else. Things that we can delay, things that we can do asynchronously. I want to talk a little bit about that concept in general. And then I want to give you some tools for your toolbox that you can use if you ever need to do one of these various things that should be done in the background. So let's go back to my original kind of little fire issue. We push the button, we create an order, check inventory, charge credit card, probably do a slew of other things. But one of these steps fail. I think that's the important part, is we're not only doing all this at the moment of the button press, but we're having an issue in that process, which causes the entire process to fail. And is there a way that we could do this in a way that doesn't impact the user so much? Think of it from an Amazon perspective. If you go to Amazon, which I'm assuming everyone here has, you put some stuff in your cart, you go through the order, you press buy, purchase, pay, what, I don't remember what it says, but you press the button where you want to exchange money for goods, and they come back not with a your order's complete, your order's ready, your card's been charged. They come back with a, what's it called, an order confirmation. So it's kind of like this process. We press the purchase button, we go create the order, and we send the order confirmation number back to the user, telling them, hey, you're good. We have your order. And we're also going to go off to the yonder, and we're going to do some other tasks. And this is kind of what Amazon does behind the scenes. You get your order confirmation, but then later, a couple hours later, maybe, you get a follow-up to your order saying that all the steps have been done. So this is the appropriate place where we go check the inventory. We charge the credit card. We send the follow-up email saying everything's good, that the mail is on its way, and here's your confirmation number, what to expect. So it's just not purchasing like this that are things that you should do in the background. We could probably come up with a list of hundreds of different tasks that should be done in the background of any application. And I kind of put them into 2 buckets. The one big bucket is on-demand tasks. So they're tasks that we just need to do sooner than later. Workflows are a good example of this. So I need to kick off a workflow. I need to do things in a certain order. And then when everything's said and done, I can wrap it up. Some examples I kind of came up with off the top of my head is emails. I have 2-3 applications I manage at the moment where we send a lot of email, and we'll send emails when someone will go in and they'll add inventory to an account. That triggers an email, but there's never something that we do at the moment the event occurs. It's always something that we postpone and do later in a background task, because email servers are wonky. If you're sending a large amount of email, it's not guaranteed that they're all going to go through. So we break it up into different batches, and then we we send the batches, and if one fails, we stop and we try again. But this is all happening off in the background. The user, the person who either is going to receive the email or who did the task that triggered the emails, they don't know and they don't care because it's all happening in the background. Payment processing, that's another thing we do. And it really depends on your application. So sometimes you can take a credit card, you can put it in a task to go process, charge the card at a later time. Sometimes you need to know if that card is going to charge immediately. I actually have a client where we do that. We need to know if the charge is going to go through at the moment the user presses the button. Services like Stripe are really quick about that, so it's not as big of a deal. But for some of our subscription stuff or those are all delayed. We do them at a much later time. We have a lot of tests like webhooks that happen in the background. So we are sitting there listening, waiting for something to happen. Data comes in, and we take the information from the webhook, we drop it into a queue, and we go process it at a later time. I also threw in here entity processing because I was working on a task while I was putting some of these demos together where we have incoming entities, for lack of a better term, and we have to go through and do some normalization on all that data. Well, that's not going to be something that I'm going to do in a foreground process that a user is involved in. It's all stuff that's going to happen in a background task. Other types of tasks. So I said there was two buckets. There's on demand, and then there's what we'll call reoccurring or scheduled tasks. And these are things that need to happen at some interval, whether it's an hourly task, a daily, weekly, monthly, or so on. And some good examples of these that I've pulled from applications I've worked on, the biggest one being reports. Today's Thursday. Every Thursday, we send 2 reports to big customers of ours. And they take 2 or 3 minutes to prepare, and then they're emailed with a bunch of attachments. That's something that we do on a background task. We have a schedule that says, all right, 3 o'clock every Thursday, go run report A, and then go run report B. I also do a lot of resource cleanup in a reoccurring or a scheduled task. So every Sunday afternoon, when we know the load on our application is going to be low, we kick off some background tasks that go and clean up some of the data. So if we have stuff that needs to get deleted on a regular basis just because it's not necessary anymore, we don't want to harm the overall performance of the application doing these calculations and such. So we do them at off hours. Now, when you're going in the background tasks, and we're going to start talking about all the different tactics involved, there's a couple of considerations that you probably need to take when deciding which route to go. I'm going to give you a handful of tools, and I'm not even giving you all the tools that are out there. I want you to think about, where are you going to even be hosting these background tasks? It depends on the type of application you're running. If you're on a desktop, which I know several people are still building desktop applications, well, you don't want to necessarily do that work in the desktop app itself. You probably want to go move that into something like a Windows service, because that can work in the background. And if it were to fail, it would automatically restart itself. It takes care of the entire process for you. With new .NET hosted services, which we're actually going to talk about as one of my tactics, we could put hosted services into our existing client app. So if you're building something now on modern.NET, you could build the background service into your app. I don't recommend it, but I'm also not building a ton of local Windows apps anymore. Most of you, I'm assuming, are probably building web apps, or you're deploying web apps. And in those cases, you again can take advantage of hosted services and do all your background work in your ASP.NET Core apps. If you're pushing to something like Microsoft Azure, which is all I do, you can take care by using Azure Functions or different services technologies. A lot of what I'll talk about with Azure Functions, you could very well just as do with Lambda on AWS or any other cloud provider. But I'm, wearing that MVP hat strongly. So I'm going to talk all Microsoft. A couple of other considerations for when you're building out background tasks, figuring out what you want to do is you want to worry about a resilient background task. So think of the case of if a task fails. So what if my email doesn't send because the email server I'm connecting to is currently down or is rejecting my messages? What should happen in those cases? Does it just crash? Do we want it to retry again at a later time? There's a variety of different ways we can solve that problem. What happens if the entire service crashes? I've done this more times than I can count, where I've just taken down an ASP.NET application by something dumb I did. And then you wait for the service, IIS or whatever, to kick in and go, oh, let me restart that process, and we'll just pretend like nothing happened. How are you dealing with these particular cases? So let's jump into a couple of the tactics. I'm going to run through them, and I'm going to talk about them kind of from a high level. I'll show you an example or two, and then we'll answer some questions. So the tactics I want to discuss first are around talking about hosted services. Then that will lead us into a discussion of either building out a Windows service or deploying our hosted services in ASP.NET Core. We'll touch on some libraries that I'm a fan of, specifically Quartz and Hangfire, which if you've never heard of either of these, take a moment and do a little bit of Googling or just wait for me to talk about them. And then finally, we'll wrap up with Azure Functions, which is my current favorite way to build a lot of different background services. But I've rearranged the topics in this talk probably 2 or 3 times. And I realized that the best way to get started in this conversation is to talk about .NET hosted services, because this was introduced in .NET 2.2. I believe I'm right on that. If I'm wrong, oh well. It was introduced in .NET Core 2.2 is what I should have said. It was provided as a way to do work in the background, to build these very strongly typed jobs that the .NET host could run for you. And they simply look like this. You have your .NET host, which could be a .NET server application, so .NET console. It could be Maui or whatnot, but you have your host, and inside of your host, you can have hosted services. And these will run automatically inside the host. You don't have to do anything except just say it exists. And you could have 1, you could have 2. Probably the most I've gotten up to is maybe 4 hosted services in an application. But there's 2 different ways to build them. I'm only going to talk about the easy button way, which is a class that implements background service, which is built into .NET already. Nothing terribly special you have to do. The background service class or instance gives you an overridable method called execute. And all that's going to happen is when your application starts, .NET's going to bootstrap this background service and execute that method, execute async. And when that method returns, it's going to stop the hosted service. So in our example that we're going to do here in a moment, we're just going to use a while loop, and we're just going to keep doing work and delaying as long as the application's alive. And we're passing in cancellation tokens, because cancellation tokens are a very good way to know when things need to shut down gracefully. So the example we're going to build in particular is what I call a folder cleanup service. It's resource cleanup. So we'll create a folder, a temp folder, and we'll put something in it, and we'll watch it get magically cleaned up by our service. Now, setting up these background services are pretty easy. So in your program CS, whether you're doing the full class namespace or you're doing the minimal API version like I have here, you go into where you configure your services and you tell .NET to add a hosted service and tell it the name of that hosted service. So this process works the same way in a .NET console app or local application as it does in an ASP.NET Core app. They both build off of the iHost process. We're going to take this and we're going to build out our first example, which is going to be a Windows service. And I know a lot of you are thinking, I don't think I've thought about Windows services in a decade. And I have built probably 2-3 Windows services in my career. The last time I built one was back in 2013 for a startup I was working with. And at the time, building a Windows service in .NET was cumbersome. There was a really great library back then called Top Shelf. It's now been since deprecated because it's not really necessary with the current .NET stack. But even with Top Shelf, you had to do a lot of heavy lifting to build an application that could work in the shell of a Windows service. Because it's not just an application you run, it's an application that needs to respond to certain types of command line switches in a very specific way. You have to know how to speak the language of Windows in order to properly build out these services. And back then, a lot of that stuff was not very well documented. We didn't have the breadth of knowledge that we have today. We also didn't have like ChatGPT, which you could just say, hey, build a Windows service for me, and it would spit out all the code. But if you want to build a Windows service in .NET 7 today, it's as easy as doing a new console app or a new .NET Worker app and installing the package Microsoft Extensions Hosting Windows Services. And this particular package is going to give you a new extension method for your .NET host called Use Windows Service. It will take care of all the wiring up that Windows requires on your behalf. There's nothing special you need to do unless you want to override any of the configuration. So this code sample here on the screen is literally what we're going to look at right now inside of a demo. So let's go ahead and switch over to some code. I'm going to open up VS Code real fast. Let's take a quick walk through this particular demo. So my program CS is up on the screen, is what you just saw on the slide. We're configuring our Windows service, and then we're setting up our hosted service, which is my folder cleanup service. Going into that class a little bit deeper, I left all this stuff off out of the slide, but if you've done any work with .NET over the past couple of years, a lot of this should seem very familiar. We're injecting a logger because we have that full dependency injection framework. And then I'm basically stubbing out the execute async method of my background service. And what this is going to do is when the application runs for the first time, we're going to execute this method. I'll go check to see if the folder I want to watch even exists. And that's up here at the top, which is just my temp folder. And while the application's running, our cancellation token is not going to be active. It's just going to be sitting there waiting for a trigger to come in later. And every 1 minute, what I like to do is go get the list of files from my folder. And I want to see which files in there are older than 1 minute. And if there are any files found that meet that criteria, Sean, I see you're texting me. Why are you texting me, sir? Zoom in, please. All right. Zoom in, zoomy zoom like that. Is that good? Give me a thumbs up on the camera if that's good.
That's good. That's good.
Good. All right. Actually, I'm going to zoom out and do this the proper way. I feel like you should just get your eyes checked, sir.
And I will.
You will.
I will.
Right.
I promise.
There. All right. We bumped it up even more. Is that good? All right. We'll go through. If we have any files that meet that criteria, we're going to delete them. That's why we're just using a temp folder. We're not deleting anything of consequence. And then we're just going to delay whatever time I have set, which is what, 15 seconds in between checks. Also passing in that cancellation token. So it's really either or. Either 15 seconds pass or the cancellation token fires. And as long as that cancellation token's non-active, we're just going to keep doing this over and over and over again, because as soon as that cancellation token kicks in or the application is trying to shut itself down, we, when that happens, we just exit the method and the worker no longer is running. If I go out to the command prompt, oh, no, let me show this as well. Go into my CS proj. You can see here I have my package for hosting Windows services. What I really like about this package in particular is I can still go to the command prompt. I'll bump up the font for Sean since he's blind. I can still say .NET run. Debugging, running this locally, is really straightforward. It's just what we expected. In the old way, you had to do a little bit of heavy lifting to get a debug run and then your actual production run when you went to actual Windows services. So this is in here checking our folder. Let me go open that in good old, what you call it. All right. I'm just going to add a random file in here. So bitmap there. And remember, it's 1 minute. So we're going to sit here and wait 1 minute. I should have made that time a little less for this demo. It made more sense when I was building it. Actually, we're just going to do that real fast. All right. So we'll go into the cleanup service. We'll add seconds. So we'll say less than 30 seconds. We'll rerun this process, which should run immediately once that, and it did. So you can see my file went away. We'll create another one just to show you it's not a fluke. Oh no, don't actually open access. What are you doing? I want new word. There we go. All right, so we'll wait another 30 seconds and this is going to delete itself. $30 more, 20 more seconds. 5. Come on, I can feel it. You're almost there. All right. And radio silence. Come on. There we go. Deleting
payback for two.
All right.
My
yeah. What's that, Sean?
Is about my eyesight.
You were breaking up on that, but I'll just keep moving on.
Oh.
All right. So that's great, but that's not useful because you can't run it that way. Let's actually run this as a Windows service. So I have all this stuff in GitHub. I'll make sure that you all get a link to it. Let's do a release build of our application. And then I need to go actually open a command prompt as an administrator. This is an important part. And we need to, oh, that's not an terminal. All right, so just deal with me for a moment. We are going to come over here. We're going to say SC. So service control, whatever it is, we'll say create. We'll call this tactic.windows service. And the bin path is going to be equal to this guy. Let's refresh. Tactic Windows service. Let's start it. Oh, I know why that failed. Hold on, because I didn't do the tactic. There we go. So we're not going to call it tactic Windows service. We'll call it tactic Windows service. One. And we'll delete it in a minute. All right, let's see. Restart. There we go. So we should be able to start this, no problem. It's now running in the background. Let's go ahead and bring our temp folder back over. We'll create another file. We'll let it sit there for a moment. And while it does that, I'll show you how to delete a Windows service if you ever have to. So we'll go in here and we'll stop. Actually, I don't need to stop. I just delete. Tactic. Window. Autocomplete's not working. All right. Oh, because I didn't stop it. All right, I'll clean that up in a moment. All right, so this should delete in a second. There it goes. So it was the Windows service doing all the work because the app's not actually running. So there you go. This is a great way to build a background service that's running on your local machine. Use this for any virus that you would like to build. Great tactic. As long as you can get the person to give you administrator access to install it, it should work just fine. So a couple notes on Windows services, just some pros and cons. Pros, it's easy to build. Way easier than it was 10 years ago to build a Windows service. I love that Windows will automatically manage it for you if you install it correctly, that is. And so if it's, I have it set up to manual, but you can also set up to be automatic. So when Windows restarts itself, it automatically turns itself on. All those services are already built into Windows for you. You just have to take advantage of them. A couple cons of this process is that it's limited to the machine you're running on or the single server. So if you're building a Windows service to deploy, it's only ever going to run on the machines that you install it on. So there's a process involved if you need this on more than one machine. The other big problem is that this is good probably for reoccurring tasks. So if you want to build something on a schedule that does some work, it's not as straightforward for what I like to call on-demand work. It's not impossible. It's just more heavy lifting that you have to do. But I could see a scenario where I just load up a Windows service with different hosted services, and they're just cranking out work over and over and over again. The individual tasks, you're kind of responsible for making them resilient. So the service itself is resilient, but if one of the background services that are running stop for any reason, maybe they just they crash. This was the big one for me. If they throw an exception and I wasn't checking for it, that background service would just stop. And unless you're checking for that sort of thing, they're not going to restart themselves. So it's a little bit of work on your part to make sure that those background services are always alive.
Kevin.
Yes.
There's a question that came in on the chat. Would this work for or with self-contained apps?
I don't see why not. I have not actually done it that way, but I don't see any reason why not. That's actually a good thing to try. I might try that after this talk. Great question.
Awesome. Thank you.
Yep. So let's take that lesson that we just learned about hosted services and let's move it to the web. And it's a very similar process going from, say, a console app or a console worker to an ASP.NET Core app. So we already understand how the iHosted service or the background service is built. Let's use that same concept and let's inject it into our web host. So the big difference here is we're still running in a .NET host, but now it's a web application. And when we're injecting our services or setting up our service injections, we tell it that we want to add a hosted service. Again, clean up folder temp service. And ASP.NET Core will automatically start this when your application starts for the first time. So we could jump into another demo. I'll go up to, what did I call my folders? We'll go into hosted service. And let's open this in VS Code. What you just saw on the screen, I'm creating a hosted service, which is identical. It should be identical to what we had before. I don't know if I changed this any. I think I changed some of the times. But it's going to check a folder every couple seconds, and if it finds anything, it's going to delete it. So let's come down to the delete code. Let me make sure. All right, deleting. I'm going to set this to every 5 seconds because we just realized that 30 seconds is an eternity in demo land. So we'll set it to 5. All right, so I've added some other stuff in here. This demo in particular, I was playing with Copilot. I was saying, Copilot, I want you to write this demo for me. And Copilot wrote this demo for me. Let's go out to our command prompt. We'll say .NET run. All right, we're also using a different temp directory because I don't want you all to think I'm still running that Windows service. I'm going to open up a Explorer window. It has nothing in it. You can see it down here. We're spinning out a log, saying every time we're checking. I'm going to create a new folder file. We'll add a publisher document this time. Oh, and it deleted. So as fast as I could add it, it was deleted. Let's see if we can add something else real quickly. We'll wait. All right. Oh, no. I don't know what I'm doing wrong. I don't want to do that. Wait. All right, so I add my PowerPoint. We see my PowerPoint. We'll let it sit there. And now it's gone because the background service is deleting that file on my behalf. So again, it's doing all the same work that we saw a moment ago with the Windows service, but now it's in this shell of our web application. You literally could put these different background services in their own assembly and share them across your applications. There's no fundamental difference between this running in a Windows service on a Windows machine or a ASP.NET Core application up in Azure or AWS or wherever you deploy to. Same fundamentals. Now, I like this process because, again, it's very easy to build. I use the iHosted service platform in all my applications. They're really nice for this type of thing. Because you've already have an existing host, you don't have to do anything special anymore to build these background services. Anyone that's ever done ASP.NET framework development, like way back in the day, like a common question we used to get was, how do you do background work in an ASP.NET framework application? And the answer was you didn't. Or if you did, it was hacky and it was going to basically take over all your resources. It wasn't something that we did commonly. Nowadays, it's just part of the framework. It's its own part of the host. Again, it will automatically start when the application starts. So when I was actually deploying an app earlier today, we run 4 instances and a load balance set. and all 4 of those are running the same hosted service and all checking queues for different work. So if one of them were to accidentally go down, I have 3 others that are always checking for updates. And we also have built-in resiliency. So if one of the services throw an exception, it's going to keep on trucking. It's going to automatically heal after that work. A couple cons. You're responsible for scheduling. So if you have work that needs to happen in a process or at a particular time or reoccurring, you kind of have to do that yourself with timers or whatnot. Like I was checking just every 15 seconds. But if I needed to do it at the top of every hour, I would have to do those calculations myself. Now, of course, if you're using something like Quartz or other custom processes that you built, this is not no longer a con. And you're responsible for resiliency. So if I'm building that hosted service, I need to make sure I'm wrapping that in a try catch, or maybe I'm using something like Poly that is going to automatically detect different exceptions that could occur, have a retry schedule. Poly's great for that. Poly's a lot to show in a demo like this, but if you haven't checked out Poly, definitely go check out Poly. All right. Well, let's talk about Quartz for a second, because in the last slide, I said you're responsible for scheduling. So if you have anything that needs to happen on an interval or some sort of recurring schedule, you probably don't want to write that code yourself. So what if you could just use something that was already deemed good by the community and use that? And that's what Quartz is. Quartz is basically a scheduling tool, scheduling library you can add to any .NET application. And it gives you a lot of flexibility about doing certain jobs at certain times or on certain intervals. So here's an example of adding Quartz to an ASP.NET Core application in particular, where we can add Quartz into our dependency injection framework, but then we're creating a job. The job in this case is going to be the cleanup temp folder job that we had seen previously. And I'm telling Quartz that whenever I use the key cleanup temp job or cleanup temp folder job, that I want it to go do certain work for me. And then at the bottom, I'm telling it to do it every 30 seconds. And it's using cron syntax, which I don't know about you, I always have to Google cron syntax every single time I need to write something that's more complicated than like every minute, because I always get it wrong. Copilot wrote this one for me, thank goodness. But every 30 seconds, I want to trigger the job cleanup temp folder, and it's going to go do that work on my behalf. All right, so a job follows a similar format as what we saw with hosted services. It's not using background service or iHosted service. This one's implementing iJob, but it's a similar idea of where instantiating an object and it's going to run the method execute when it's ready to do that work. To set Quartz up in an ASP.NET Core application, there's a couple injections you have to do. I listed them here on the slide. If you're working in a .NET console app, you should be able to get away with just the Quartz package or the Quartz extensions dependency injection package as well if you're using .NET dependency injection. But for the fancy things I'm going to show you now, you should have these 3 packages. So we'll jump into another demo. So what I did when I built this was I took the web hosted service demo and just copied it. So we can go into our program CS. Unresolved dependencies. Oh my goodness. Let's take a look. I create a new job, which tells Quartz that I'm going to give this a simple name that I can use anywhere in my application. So maybe there's somewhere in the app, someone does something and I want that to trigger a job on my behalf, I can use a magic string name to identify what work I want to see done. Whenever Quartz sees that key, it's going to go instantiate the cleanup temp folder job object, and it's going to execute it. I've done some stuff here to make sure that jobs don't run concurrently. I've had that bite me in the butt a couple times, where if it's something that you're looking at resources, but two jobs are running at the same time, they could kind of step on each other's toes. So I just tell them, don't do that. And then we're setting up the trigger. So every 30 seconds, I want to go run the job key. So clean up temp folder job. And here's my cleanup temp folder job. We're implementing iJob. This is Quartz stuff. And specifically, it's giving us the method execute with some context. So what's really cool about the context is you can get information about when the job was kicked off, who kicked it off, when's the next time it's going to run. If you need any of that detailed information, it's all inside of there. But it's a similar process that we saw earlier, where I'm going to go to my temp folder, look at all the files inside of it, and if I see any files, I'm going to delete them. And because I'm not really doing anything asynchronous in here, I'm just returning a completed task. And did I set it? Let's set this to 15 seconds because reasons. I'm going to say .NET run. All right, so this is running. And what folder did I set it up on? I think I set it up on the same folder. Yes, I did. All right, I'm going to add a new file in here. And we'll wait 15 seconds for the job to run. All right, just ran. You can see it down here, finish executing, and the file is deleted. So same idea as before. We're doing the work in the background. And I didn't really show this earlier, but I did add it is a ASP.NET Core app. So we can go to our endpoint, and our work still happens the way that we expect a web application to work. So if this was running say a full Blazor app, that still runs the way that you expect it to. Now we have this background service that's doing some work periodically. In my experience, this doesn't really impact your apps at all. They're running in the background. They're taking up minimal resources. As long as you're not doing any real heavy lifting, like memory intensive, CPU intensive stuff, these background processes are not going to get in your way. But sometimes they do. Jump into slides. So some pros and cons of Quartz. I love the precise scheduling and timing. So you can do mostly interval schedule based stuff. I need it to happen every hour. I need it to happen every Friday. I need it to happen every third Thursday of the month. You can set up those schedules and Quartz will take care of it for you. You can also do one-off jobs. So if you have a part in your application where you need to do a task, you can ask Quartz to handle that task for you, and it will go off and make sure that it gets done. You can set up a job server. So maybe you don't want that work to happen in your ASP.NET Core app. You can set up a separate service that runs Quartz, and there's a data store between them. And every time you need work to get done, this job server will do that work. I've actually never done that with Quartz before, but the documentation is pretty straightforward. It'll teach you how to do that. A couple cons. We're dwindling this list down a bit. You're locking into the way that Quartz does things, and Quartz has changed their API at least more than once. So you get to a point where if you want to update Quartz, you have to rewrite a whole bunch of code. Not a ton, but It's happened to me at least once on different projects. So if you want to lock into the way a library wants work to get done, that's the way you're going to have to go here. It was a bit of work to get dependency injection to work properly with Quartz because they want to do everything their own way. I'm a big fan of libraries that tie in directly with the way .NET does stuff. But if you go through the example I have up in GitHub, setting up DI with Quartz is pretty straightforward. Not a big deal. Well, let's move up to was this like number 4 on my list, which is Hangfire, and I love Hangfire. It's basically a job server that lets you set up one-off tasks on a schedule or on demand, and you can also set up reoccurring tasks, and you get this great little UI when you set up a Hangfire application. So Hangfire lets you bring your own code. So it's not opinionated like Quartz is for a lot of common tasks. So Quartz was expecting you to have an object that implements iJob, which gives you an execute method. With Hangfire, you could just bring a class of your own. Like here's just one I created called cleanup temp job folder. And it has 2 methods that I could change the name of them to whatever I want to. I don't have to use execute. I don't have to use generate. I could use Bob, foo, bar, whatever. And Hangfire is not going to care, because when I set up Hangfire in my application, I'm basically telling it what methods I want to execute at a later time. So this is a little bit beefier code than before. So let's go over to the demo. Hangfire.code. Everything opens on the other screen. I don't know why. Let's take a look here. So the first thing you have to do is you have to NuGet install the Hangfire package. Because I'm running on ASP.NET Core, I also have to install the ASP.NET Core package. And the other thing I have to install is some sort of data store. One of the cons of Hangfire, and we'll talk about it in a moment, is that you have to have some sort of data store backing the server, because it wants to track the progress of every individual job that it does, and it needs some place to put that data. The simplest way to get started is with SQL Server. If you have SQL Server, it's not the best place to put your data, and I have some stories about Hangfire and SQL Server I can tell after we're all done here. But if you're just trying to get up and running, use the SQL Server connector. It's fine. Inside of our program CS, we set up our injections by adding Hangfire and telling it to go to our database. I'm hard coding all this stuff. I actually forgot to do this before I jumped in. I need to create that database first, or else it's going to fail. So I'll go off and do that. But then I'm also going to configure a reoccurring job. So a recurring job is something that happens on a schedule. We'll set this to 15 seconds. But every 15 seconds, we're going to tell Hangfire, instantiate my object clean temp folder job. And I can just pass a lambda telling it what method I want to execute. I can pass in parameters, and Hangfire will automatically go off and do that work on my behalf. All right, some more stuff. I have a method in my ASP.NET Core app called generate. And when I go to the generate endpoint, I want to tell Hangfire to go do some work. This is the equivalent of maybe scheduling emails to get sent. So my endpoint happens. I tell Hangfire I want to schedule a method to be executed at a later time on my cleanup temp folder job, and that method is called generate. And I'll tell that to happen 30 seconds later. We'll knock that down to 15 as well. The job is still no big difference between what we saw earlier and what we're seeing now. I'm still creating my temp folder, which is clean. Yep, clean up temp folder. And we go through, see if there are any files in there. If there are, we delete them. We get in, we get out. Notice one of the things I don't have to do here, I really don't have to do a delay. I don't have to do a while loop with the cancellation token. I just do the work that I would need to do if this method was executed. My generate method, this is going to do a lot of heavy lifting for us, is I'm going to give my temp folder and just generate 50 random files in that folder to be deleted later. So I'm going to make a mess and then clean up afterwards. Last part, because it's Hangfire, I get a fancy UI dashboard, which will show, and you have to wire that up or else you're not going to have it. Let me connect to my local server real fast. All right, close all this stuff. You know, I love SQL Server, but I wish it would clean up after itself. All right, we'll create a Hangfire demo database. If you don't create that, Hangfire will yell at you, but you don't have to create this stuff inside of it. Hangfire will take care of that automatically. Let's say .NET new run. Okay, so we can look at the logs, kind of see what's happening. It instantiates itself. It's going to use SQL Server. It's created. We go into the table storage down here. Oops. We can see it created all the Hangfire tables automatically. I never touch these. I just let Hangfire deal with them. If you upgrade Hangfire and it needs to do any sort of migration for data, does that all automatically. It's really great about keeping track of itself. One thing I will recommend is don't put Hangfire in the same database as your actual data, or the same database itself. It can be on the same server, just put it in a different database. Again, I have stories. We can talk about those later. All right, so the cleanup job is sitting here just doing its thing. Let's go to our application.
Kevin, we got a quick question on Hangfire.
All right, give me a quick question.
It says, could the execute and generate methods be async and await enabled?
Yes.
And does it support DI?
Yes, yes, and yes. Hangfire is a
Awesome.
first-class .NET citizen. So yeah, the examples I have don't need to be async, but if they did need to be, these could be async await, or async task, and do your work. Hangfire doesn't care. So the big difference will be here. So when you set up your Lambda, is you're not going to await your Lambda. Hangfire will take care of awaiting it for you automatically. But the actual tasks themselves can be, as long as it returns tasks, Hangfire will await it. Great question. All right, let's go ahead and generate. So that did some work, I think. Was it too fast for me? All right, either I am looking in the wrong place. That might be right. I might be looking in the wrong place this time. Temp folder job. Oh, I named it differently. I named it differently so no one would know I was. There we go. Oh. There we go. Okay. Generate. All right, I swear it's doing work. Oh. No, so you see it's doing work here because it cleaned all that stuff up. Was I just too slow in the folder? Huh. I almost feel like I'm just too slow. All right. hold on. We're going to get the timing of this right. Well, why is it not? All right. So obviously you can see it's deleting stuff that it's creating, but I'm not getting it in my actual file explorer. Weird. Oh, there it goes. All right. Jeez. All right, Windows. I hate the new Windows Explorer so much. All right, so you all saw the files there. Hopefully, so let's run that again. Do refresh. Huh. Oh, because I'm dumb. I'm dumb. Let's go look at the UI. I forgot I'm delaying the job 30 seconds. All right, this is the Hangfire UI, everybody. Let's go run this task again. So it's not running the task right away. It's scheduling the task to happen later. I forgot about that. So if we just let it sit here, this will update automatically. Let's go ahead and so this will say it's going to execute in. All right, just executed. Come on. All right. I feel like I just have a timing issue here, but let me go ahead and show you what's happening under here. When you schedule something in Hangfire, it's going to strongly type the request. So notice in my code that when I create the reoccurring job or the background job, I'm telling it directly what method to change. There's no magic string involved. If I misspell this just won't compile because I've misspelled the method name. I can pass in parameters. So we'll pass in, we'll say Sean, generate Sean. We'll go into the method itself and we'll say name. And we'll pass in all the fun log information. We'll restart this. Go back into our regenerate. Go look at that regenerate method. So you see here, we're going to call a method called Sean. Generate with the parameter Sean. So if you pass in a standard type, so a string, integer, you name it, it's just going to get passed in here. If you pass in a complex object, it will automatically serialize itself to JSON. So you can see a whole bunch of JSON in here of what your object would be made up of. They don't recommend passing in large objects that because of serialization and deserialization, but you use your code the way that you would expect to use your code. The only difference is you're doing it at a later time. And then you have reoccurring jobs. So here's my cleanup execute, which last execution was a couple of seconds ago. It's going to execute again in a couple seconds. It tells me what the cron is. I wish it would translate that into actual time and tell you this is every 15 seconds, but it's not. If for some reason you need to delete it, you could delete the job and it won't ever do that reoccurring job again unless you restart the application, and then it re-adds the job. Other nice thing is you have retries. So let's go ahead and do a test here. So generate will just throw a new exception. If I can spell. Something went wrong. Thank you, Copilot. We'll rerun this. We'll say generate. Now it's queued up. We'll wait 15 seconds. Wait 15 seconds. All right, because as soon as it runs, it's going to crash.
Here in a second, I'll bug you for some more questions.
Go ahead.
Okay. When do you draw the line between firing a background task and having a dedicated worker role listening to a message queue?
That's a great question. I'm currently in the process of, so I talk about Hangfire, and I love Hangfire. For our application, we're actually moving away from Hangfire. Here in a moment, I'll talk about the cons. Hangfire is really great when you are running it in the same ASP.NET Core process that you are deploying. So even if you have multiple instances of it, it's great for that. We were running into issues where we were trying to do so much in Hangfire, it actually made sense to have Hangfire have a Hangfire server. So we would issue the requests for work to get done, and then there was a server that would go and do the work. And that sounds great in theory until you remember that Hangfire is trying to strongly type all this stuff. Well, now we have to take all of our code for our jobs. We'd have to put them into a shared assembly, share this assembly across the web app and whatever our worker app would be. It became complicated, and it's still complicated, but we decided it's just easier to get rid of Hangfire in this case because we've outgrown Hangfire. There's still a lot of facets of Hangfire I love, but we're at the point now where we're moving to queues and we're having dedicated workers because it's easier to work with things like magic strings in those cases than it is to work with the strongly typed stuff. So I guess that's the answer is you will eventually outgrow it, maybe. But if you are only doing maybe a couple dozen different types of jobs, Hangfire will work great for you. So
Right,
I had a failure.
Question.
Yes. Go ahead.
It says, what's your strategy for retrying for transient faults or definitely non-processable tasks?
Oh, that's a great question. That's a long question. Let's wait till the after show to kind of get into some of that theory.
Okay.
Because there's a lot of ways that could go. If it's something, so obviously if it's something you can recover from easily, do your best to recover it. If it's a hard failure, usually what we will do is we will just notify someone. That's kind of the easiest way to go in a lot of cases. If it's something that's catastrophic that we can't recover from, we'll just notify. So that might be an email, that might be a Slack message saying something really bad went wrong. Someone with a brain needs to look at this and figure out what the next steps are. That's not always the best case, but that's kind of the easy solution for a lot of stuff that we do. But again, that's probably a longer conversation for afterwards. I love that question though. All right, so I did have a catastrophic error. Something went wrong. We can go look at the job itself and we look at the job history and it will tell us something went wrong. Give us a call stack saying, here's where it went wrong. Go take a look. And it's automatically going to set it up to retry. And it'll do this on a schedule. And every time it fails, it waits a little bit longer to try it again. And eventually when it just fails up to 10 times, it's going to go into this little failed category. So I can go back and look at all the failed jobs and see what we could do. So I guess kind of go back to the question from a moment ago. We have an app that does payouts through PayPal. And the tactic we took there is because PayPal is a piece of crap, it doesn't always work every single time you send a request to it. And what we do is we actually have that as a hang fire task. And if it fails consistently, it will go into our failure category here. And we have to go and do a little bit of manual work on our end, but we built some tools around kind of recovering from when that's a case. But that's a good case to have. You don't want a failure that you don't have logs for. It's better to have a failure, even one you can't recover from, if you have logs, so you know exactly what happened. You have all your information. You can go back and you can deal with it. Hangfire does a really good job of that by giving you all the call stack information. Side note: one big issue I have with Hangfire is they don't allow you to put any information in these logs. There's a third-party library that's says, oh, we can help you do that, but it doesn't work very well. So if you want to put any information in these logs, which I figured everyone here would want to do, they don't make it easy to do that, which is another reason why we're kind of moving away. But maybe in those cases, you're relying on the .NET's logging capabilities to pick up some of the slack. There's also a service here, so you can run multiple servers. You can see all of them, how often they're updating. When we update job servers in our application, we'll just come here to do a gut check to make sure they all come back up correctly, because we can see it. But that's actually enough about Hangfire. I do love Hangfire though. So if you just need to get into it and you want to do something quick and easy with your own code, Hangfire is a great solution for you. All right. So pros of Hangfire: super precise scheduling and timing, like up to, we're not talking like up to the millisecond, but within a couple seconds of when you need something to happen, it's going to happen. It's easier to set up one-off jobs than I think Quartz or any other process. So if you need to send that email immediately, put it in the Hangfire. Hangfire will take care of making sure that the email gets sent. Strongly typed jobs, which I think is a great pro if you're taking existing code and you just need to add some background services to it. So go run this method later. That's what Hangfire is really good at. The UI is amazing. It's not like amazing to look at. It's just ugly bootstrap, but it's great to have a UI for your background tasks because you can just see at a glance what's happening, what's currently in progress, what's failed, why did it fail. It's really useful to have all that stuff. The cons: the external data source is required, so you have to have SQL Server or something. The something that you would want to use is Redis. The problem is it's paywalled, so you got to pay that enterprise license if you want to use the good data stores. And setting up a separate job server is a pain in the butt. Discussion for a later time. About the data stores, we've done a good job kind of architecting around SQL Server. You don't want to do a lot on a SQL Server because Hangfire is very read-write heavy. It's constantly checking for new jobs to be done. It's writing job statuses as they occur. If you put this on the same server as your other production stuff, you want to limit the resources to the Hangfire server. I have basically DDoSed a SQL server in Azure before because of Hangfire. Again, a much longer story for a later time, but it's what you would rather do is use Redis, and because that's amazing. And there's also some third-party projects out there about using things like Service Bus or Azure Storage, which I think would be well. But if you don't have those, but you do have SQL Server, you're good to go. Last but not least, I'm not going to do the full demo of this. I want to touch on the topic, and that's Azure Functions. And this is kind of what we're moving to in our application because it checks all the boxes for us. Azure Functions, again, should probably be its own talk all in itself. But the idea is that you have a variety of triggers that kick off functions, and they'll go off and do work for you. So here's an example of a timer trigger. where every 30 seconds, this function is going to execute and it's going to do some work. Now, this might not be the only type of trigger that you want to have. If you go to the .NET docs, there's a complete list of different trigger types. So in this case, this is very Azure centric, right? If I want to know when a new file is added to blob storage, I can get a trigger and go and do some of that work. If I'm using Event Grid or Event Hubs, I can get triggers on events that come in. Standard HTTP triggers, so webhooks. We use those for webhooks extensively because we use Stripe. We listen for Stripe webhooks to our Azure function. We go off and do the work, and it's yeah, we have no problems at all with that stuff. All the way down to one of my favorite topics, Signal R. You have Signal R triggers. Timer triggers we use extensively. Queue triggers we use a lot as well, just to manage work. The big benefit of using Azure Functions or serverless in general, like the benefit of serverless is not that you don't own the server, like you don't have to manage the server. That's a benefit. The benefit of serverless is scale. We go through, so something we just went through with one of our projects is we had an app is running on a Node.js. There's a Node.js app that would go to MongoDB and would pull out however many hundreds of thousands of documents in this collection, and would basically for loop through them. It would go hit a endpoint, HTTP endpoint, do some data checking, and come back and update, rinse, repeat. And they had spent so much time and energy trying to architect a better for loop that it still took forever to go through all this data. We took that process, and instead of big old for loop, we put everything into a queue. And that part was pretty straightforward. Get all the data from the database, drop the items into a queue. We would do them in batches. And then serverless Azure Functions would spin up and would just start pulling stuff off that queue as quickly as it could. And the cool thing about Azure Functions is if it detects a lot of back pressure in the queue, it's going to spin up more instances and then more instances. And you watch this queue with 500,000 items in it, and all of a sudden it's got 250,000 stuff in it, and then it has 100,000 things left in it. And you refresh and say you've got 50,000 things left in it, and all of a sudden it's got nothing left in it because it's processed all that data, and it took a fraction of the time that it used to take with a for loop, or the way that we would have done it with some of the other methods that we just talked about. So we plow through all this stuff because we have Cloud Scale, and Cloud Scale is amazing the first time you see it actually work. So all that said, we have all these different triggers that we can use for different background tasks. If you go look at my demo that I have in my my GitHub repo, I'm basically just using a timer trigger to go hit an endpoint and put some data into blob storage. And I think the next iteration of that demo is going to be, once it's in blob storage, we're going to go do something to the data. So we're going to have two triggers that will execute back to back, basically because these different events occur. All right, so a big pro of Azure Functions, just kind of wrapping this up. Again, precise scheduling and timing. If I set up a timer trigger, it is going to execute within a second or two of when I need it to exactly. I mentioned a report we run every Thursday. That's a timer trigger that executes every Thursday at 3 p.m. Eastern time. We have a lot of trigger options, and the Azure teams are actually adding more as they come up and they see the demand from the community. Cloud Scale, you cannot argue with Cloud Scale. It is amazing to just process a butt ton of data in a very short amount of time. It's very fun. All the tasks are independently resilient. So if any of my Azure functions fail, actually it depends on the Azure function. So if it's like a queue trigger, it'll automatically retry itself. It'll retry itself up to 5 times, and then it's considered poison data. And you can get a notification when that stuff happens, but it's going to keep retrying. You can go into your logs and you can see each individual function execution and whether or not they succeeded or they failed. It's not as nice as what we saw with Hangfire, but it's functional in the portal. You also have things like durable functions, which I don't like talking about because I don't like durable functions, and I have a lot of reasons for that. But durable functions try to do sort of what like Hangfire was attempting to do. Also useful if you have any functions that need to go longer than the 10-minute timeout. Again, like Azure Functions is its whole topic all by itself. I should do a course on it. A couple cons of Azure Functions is the Azure requirement. So serverless is cheap. Like I do a ton of work in Azure Functions and it costs like $3 a month. And I feel like that Azure function is just going all the time. So if the option is between running your own service and say like an app service or something that costs, $90 to $130 a month, or running it serverless, which is $3 a month, and doing more work faster, it's a really good trade to make. So all that said, kind of wrapping this up, you should be doing as much work as possible behind the scenes. If you have anything that doesn't require immediate feedback to the user, it should be done in some sort of background task. And my hope with this talk was that I gave you a bunch of options for ways to implement this, because software development is a journey. We all have different opinions about how things should be done, but it's really nice to have a variety of different tools in our toolbox, because you never know when you're going to show up to a gig and someone says, well, we have a Maui app that we're doing all this work in, or maybe worse, you're doing Windows forms and we have to do all this background processing. Is there a better way to do this? And you go, yes, we can build a Windows service and it'll do all this work on our behalf. But all that said, thank you all so much for hanging out with me tonight. I appreciate it so much, and I'll hang around for a little bit, answer any questions, and have those deep conversations that we were promised. But
thanks, Kevin. I really appreciate it.
Thank you, Sean, for having me. I appreciate it so much.
Yeah, absolutely. Let's see, another question has come in. What's the best way to get notified when something goes into a poison queue?
Oh, so we actually have queue triggers for our poison queues. What we do, actually, no, we don't. We stopped doing that because if you have a lot of queues, you don't want to set up a trigger for each individual queue potentially. We have one. What do? We have one timer trigger that runs every 5 minutes. And it just checks to see if there are any queues that end in poison, and do they have any messages in them. And if that happens, we have I get an email, and then we have a message go to our Slack channel. Because usually if the poison queue happened, it's something we want to go take a look at. But that's how we handle it. I tried to do a bit of research on that particular topic, and I didn't find anything better. So we solve it that way, not because it's the best way to do it. It's because it's the only way we could figure out how to do it with the tools that we had. So if there's a better way to do it, I am all ears.
And okay, along the same person. So the easy way in the Azure portal to configure without code.
You were cutting out a little. Actually, I have the chat. Hold on, I can see this as well. So there's no easy way in the portal to configure that without code. Not that I'm aware of. You could set up Azure Monitor, I think. I believe Azure Monitor can check that for you as well. Don't quote me on that. That should be something Azure Monitor could do too. Is if you see a poison queue, send a message, send a text message. Do all the Azure Monitor stuff. I feel like I saw that solution somewhere, but I'm not quite sure.
Okay, there's another question came in as well. We use Azure Web Jobs for daily cleanup and reporting. Would you recommend moving that fire or?
I love Azure Web Jobs. So a long time ago, Azure used to have worker roles, and they got rid of those. And all a worker role was a console application that ran in the cloud, and it was easy to deploy, and had this little wrapper around it. So they got rid of those in lieu of web jobs, which I think web jobs are fine. Using web jobs with something like Quartz maybe works well as too. My problem is I think the deployment story for web jobs is a little bit cumbersome. It feels like an afterthought, or someone had a really good idea, started working on it, and then kind of abandoned it when it was time to go to production. So all the Hangfire workers that I was talking about earlier, we run those in web jobs. So it's just a console app that talks to the Hangfire data store to figure out what work it's going to do, and it runs. We don't run those web jobs in the same app service as our primary apps. We have a dedicated app service plan for the jobs. We also use the free tier for those. Again, because Hangfire will basically take over your app, just resource wise, if you let it, you do all the configuration to try to scale it back. So yeah, that's what we do.
All right, another question. Is it better to have one giant queue and use message filtering for the consumers, or have many queues and not use message filtering?
I prefer message or having many queues. That's just how I am. I think it's easier to look at a list of queues, and as long as your naming scheme's right and easy to figure out what each queue is for, we prefer doing that. But I don't think it's wrong to have one giant queue and then filtering the messages. It's just a little bit more work you have to do on the producer and consumer side. But I don't think it's wrong. I just prefer having many queues. The big thing we do in our app is we go through and because queues are basically magic strings, is we have static strings for all of our different queues. So we're passing around strongly typed strings all over the place. We're not using the string names directly.
All right, cool. I am putting links into the chat. Yeah, absolutely. And there's even I posted this earlier. I'll post it again. There's a website, crontab.cronhub.io, that I've used in the past for creating the cron syntax. I also put in,
which doesn't work for Azure Functions.
It doesn't?
Azure Functions uses a slightly different syntax called incrontab or incron. I forgot the gentleman's name in the community. Swimberger, Neil Swimberger. He has a tool called incrontab that helps you build cron for Azure Functions, and it's so normal cron will work like 50% of the time, but then there's this other like weird 50% where it doesn't work at all and your stuff never fires. So just a small thing for Azure Functions that's bitten me at least 5 times.
A link that I put was, and it's to Overflow, is how you can move cron information that is in the trigger info of the beginning of the Azure function. You can move that to an app settings area, and That way you can change your timing without having to redeploy your Azure function.
Oh, that's a cool idea. I never thought about that.
Yep, you can do that.
I love that.
All right. Any other questions? All right, so what I'm going to do is we'll do the official send off here, but then hang around. I've got some more questions for the group. So hang out just a moment, and thank you, Kevin. I greatly appreciate it. And let me see if I can take over and stop the recording.